Okay, so 2.1.1, we need to factorize 2m to the power of 2 minus 5m plus 2. What I picked up when I marked this particular question is that quite a few learners used that method that one uses when we have very high coefficients for the first term. The cross product method, or I can't remember even what the name is now, but the method that one uses when you sit with very high coefficients and you're not able to factorize this quickly or normally like you would normally do with very low coefficients like 1 or even 2. This coefficient is larger than 1, but just by 1. It's also a prime number 2, and the third term is also a prime number 2, which means it only has two factors, 1 and the number itself. So this doesn't really require you to go and do the whole cross product, long method, long division looking type method. You could simply have just taken this and open up your two brackets and factorize the first term, because it can only be 2m and m, and the last term can only be 1 and 2 again. So you just needed to make sure that you choose your factors, of course, in a way that allows you to end up with a negative 5m as your middle term. So you would obviously need to put that the 2 and the 1 that comes from here, that 2 you would probably want to place here so that you can multiply it with that 2 and get a 4, which will bring you, of course, much closer to that 5. So that looks pretty straightforward. In other words, I'm going to put a 2 here and the 1 there. That will give me 2 again. And in terms of the signs, positive 1 and positive 2 will give me this positive 2 again, but then this will give me positive 4 and positive 1, which will give me positive 5, and I need a negative 5. So I know, of course, that I need to choose both signs to be negative. Remember, third term positive, so both signs will be the same. In this case, we will choose negative 1 and negative 2. Negative 1 multiplied by negative 2 gives me this positive 2, but then also negative 4m and negative 1m gives me negative 5m, which is the middle guy over here. So that basically works out, and I did not have to use any fancy long tedious methods. It's simply identifying that I've got the number 2 as my coefficient, which is not a high number, it's not a big number, which means my factors that I have to play with will not be a lot, because again it's also a prime number, meaning I only have two factors. So that's 2.1.1. 2.1.2, we have negative 2x to the power of 3 minus 6x to the power of 2. Now, just to go back to 2.1.1, if we think back to the rules of factorizing, the first thing that you should always check for is, can I take out a highest common factor? So even here, we didn't really check for the HCF, because if you do this often enough, you would obviously know that there is no obvious HCF here. You could play around with fractions and make things very complicated, but that is really not necessary. So in other words, I do not see anything common between the three terms here, so I would then go on to the other types of factorization. This would not be a difference of two squares because there's more than two terms. This would not be grouping because it's less than 4, so it is very obvious that it is a quadratic algebraic expression. In other words, it has the form of that trinomial, and we of course then went ahead and factorized according to that. For 2.1.2, we will go, well, this does not obviously look like a difference of two squares. It does not look like a trinomial. So you would sort of default back to those steps, meaning you would check first, is there HCF? If not, is it dots, difference of two squares? If not, is it a trinomial? If not, is it grouping? So you'll go through these guys in that order. And if we check for number 1, of course, it is very obvious that there is a highest common factor. So in other words, what is the highest number that can divide into both of these terms? In other words, what can I take out of here? What is the most I can take out of these two terms? Now, you could take out, if you are very observant, you could take out the negative, because the negative is actually common between the two terms. Both terms have a negative sign. And then in terms of the numbers or the coefficients, the highest coefficient or number you can take out is 2. And then in terms of the variables, the highest you can take out is an x to the power of 2. So I open then up my bracket, because what I've just written down here now is my HCF. In other words, this is the highest number that can be taken out and that can divide back into both terms. So what's left is, what happens if I take this highest common factor and I divide it into this term, what will remain? In other words, if I did this, if I took the first term, which is negative 2x to the power of 3, and I divided by my highest common factor, which is negative 2x to the power of 2, what will come out of this? Well, I would then cancel out the negative 2's, and x to the power of 3 divided by x to the power of 2 will give me x. So that is what's left in my bracket. And notice the signs was very important here. So if I ask myself the question, what happens if I divide the highest common factor into the second term, which includes that negative sign? I can simply go and do that same exercise. In other words, negative 6x to the power of 2 divided by the HCF, which is negative 2x to the power of 2. So here, negative 6 divided by negative 2 gives me a positive 3. And x to the power of 2 of x to the power of 2 cancels out, it's 1. So the answer here is plus 3. So you'll notice that if you've taken out the HCF, in other words, the highest common factor, when you factorize and you're done factorizing, you should not be able to take out the highest common factor again. That's the whole point of taking out the biggest one, so that you don't have to factorize again. If you did not take out the biggest one and you find that you still have some, you can still take out the HCF again, you can just repeat the process and you will just have an extra step or two. You actually won't get that wrong, because you should eventually end up with this anyway. But there we have it. If I multiply this back into my bracket, I should get the first term again. And if I multiply this back into this bracket, I should get the second term again. And that is how you can test. 2.1.3, we are still busy factorizing. We need to factorize 3t to the power of 3 minus 81. And here we have 3t to the power of 3 minus 81. We are going to factorize this again by following our rules, meaning, can we take out a highest common factor? That is the first thing that we should try to do. And once again, simply following the rules will ensure that you do not make unnecessary mistakes when it comes to these types of problems, meaning factorization. If I look at 3t to the power of 3 minus 81, I've got two terms. And the first question is, can I take out a highest common factor? And the answer is yes. If I take out the number 3, which is the highest number I can take out of both terms, I would be left with t to the power of 3 minus 27. And if you're not certain, just use your calculator to get on with it. So that's t to the power of 3 minus 27. That is what's left in the bracket after I have taken out the highest common factor. And then, of course, the next thing we do is, can I factorize some more? So, of course, I should not be able to take out the highest common factor in my bracket if I've taken out the highest common factor the first time properly. But then the question is, can I factorize this by other means? And you should identify that this is the difference between two cubes. So t to the power of 3 is a cube, 27 is a cube, and this is the difference between two cubes. So I can continue with this question. And of course, if you look at the mark allocation, it's 3 marks. Not really a great indication of the fact that you should continue, but nevertheless, you should notice the difference between two cubes. So the 3 remains outside, and I know with difference of two cubes, I open up a little small bracket and a slightly bigger one. I factorize the first term as t and minus, so in other words, I take the cube root and that's a better way of just explaining what I'm doing here. The cube root of t to the power of 3 is t, and the cube root of 27 is 3, because 3 times 3 times 3 is 27. Then in the second bracket, I write down what will remain to get to t to the power 3 again. And like if you've paid attention to our, let's call it shortcuts that we learned when we dealt with how to factorize these cubes or difference of cubes, we know that if it's the difference of two cubes, our middle term will carry a plus sign. So that will be plus, and that would be 3t. In other words, the middle term comes from taking these two terms, multiplying them together, and of course the appropriate sign according to the rules. In other words, it's a difference of two cubes, so I know that my middle term will carry a positive, the opposite sign. And then the last term will be given by, well, what do I multiply this negative 3 with to get negative 27 again? And that would be positive 9. So positive 9 times negative 3 gives us negative 27, and that should then finish off your factorization. Your difference of two cubes is now fully factorized. You should not be able to factorize this quadratic any further. If you play around with the factors of 9 to get 3t, you'll find that you will not be able to do that with or via normal means. So this is it, you are done.